Okay, let us see how we handle. This is a question which was sent by someone. So let us see, it was about proof by induction. Proof by induction is a topic, it's a subtopic under calculus or in pure math, which we say it's under series, the upper parts of the series. When you go deep there, that's when you find the proof by inductions there. So this one, proof by induction, that this is equaling to this. What we do, we say this is the left hand side and this is the right hand side. So the steps are always 3. You prove it's true for n is equal to 1. Some people go on even to prove it for n is equal to 2, but that is also okay. Then assume, the second step is always the assumption step. Assume it's true for n is equal to k. Then if it's true for n is equal to k, if your assumption is right, then it should be true for n is equal to k plus 1. So these are the only things we are going to mainly use. So I told you that most of the videos, also series work is there. You go to my YouTube channel, go into the playlists, then down there you will search through, and I told you also you can change the quality of the video. Pointing at the video, there are some 3 dots there. You click on them, go to quality, this is 480, then go to advanced setting, then you will see and you choose the quality you want. So let me handle this. So I'm going to start with step 1. Okay? So prove it's true for n is equal to 1. So step 1. Step 1. So when n is equal to 1, we say we have 2 parts. We have the left and then the right. So I'm going to say this is going to be my left hand side. So my left hand side. Now, these ones are multiplication. It means these are this point here. It means 4 multiplication. This is 1 times 2, 2 times 4. So even here, this is times this times this. So these are symbols, or that implies that it's multiplication. So this is 1.3. When n is equal to 1, on the left it means that take only one term. So this is the only term I have. So this term here. So I take one term. So 1 times 3 is the same as 1 times 3, which is going to give me a 3. So that is my left hand side. Then I come to the right hand side. Now on the right hand side, we just substitute in the right hand side. We just substitute where there is n, we put 1. So we have 1/6 into n plus 1 into 2n plus 7. So when we put in a 1, we have this as 1/6 into 1 plus 1, whereas then I'm putting 1. So 2 into 1, then plus 7. So this is going to give us, this is 2. So this will be 2/6 times, this is going to be 9. So this is 3. Let's have on this side. We are getting a 3. So it's now that the left hand side is equal to the right hand side. Is equal to the right hand side. Then you can even go for when n is equal to. Okay, let me try when n is, but you can step at this step, but you can stop at this step. But let me go to when n is equal to 2 and you see what happens. When n is equal to 2, now this means that we are going on the left, you are taking the 2 terms. So this is the first term, then plus this is the second term. So those are the 2 terms on the left. So my left hand side will be, now I take 1 times 3, then 2 times 4. It's the same as 1 times 3, then 2 times 4. So this is going to be 3 plus 8, which is going to be 11. Then you come also and put in the right. So the right, we just substitute the value of n. So our right hand side is going to be, now where there is n, I have 2/6 into, when I put here 2 plus this I have 3 into now, when I put here 2, I have 4 plus 7. So you see this and this, they are going to go with that, and so also you have 11. So that your left hand side is equal to the right hand side. Even if you go for 3, it's okay, you can also go for 3, so, but you see that they are going to be the same. Now, from there, we come to step 2. Step 2. This step 2, now assume it's true for n is equal to k plus 1. Assume it's true for n is equal to k. So this is an assumption step. Now, if it's true for n is equal to k, it means that where there is n, we are going to put k without. So I'm going to be having 1 times 3 plus 2 times 4, then plus. Now you see I have now k over, so it's just k. It's just k. Now where there is n, we are substituting our k. So now I have k, where there is n, we are putting k. So k plus 2, the whole of this is equal to 2, k over 6 into k plus 1, then into 2k plus 7. So when n is equal to k, where there is n, we put k. Now this is an assumption step. Then step 3, now it's proof for n is true is equal to 1. So our step 3, for n is equal to k plus 1. Now, for n is equal to k plus 1, this just shows you that here we have k terms, but here we have k plus 1 terms. So what does it mean? So if these are k terms, it means that to get k plus 1 term, we are adding 1 term. But the question is, how are those terms added? Now you start from here. You see from 1, we have 1 times 3. Then here from 1, here the first figure, we add 1 to get 2. Then on the second, we also add 1 to get 4. So that's the relationship when they are forming terms. So meaning, first of all, these are k terms. So the k terms, I have 1.3 plus 2.4 plus. So these are k into k plus 2. Okay? This is going to be now the k terms. The k terms. Now, I want to add on 1 term. But I'm seeing the relationship they are using here to add on 1 term. You see that? When they, from this term, you see, when I'm from this to this, I add 1. You see, from 1 to 2. From 3 to 4. So meaning, this I add 1 if I'm to get the next term. Then this I add 1 to get the next term. So meaning, if I'm on this, these are k terms, so I need to add 1 term. But the relationship is, on this one, we add 1. Then on this, we also add 1. So k plus 2, now plus 1. So that is the idea. That's, you start it from here. So equaling to, now this side, when n is equal to k plus 1, the whole of this is equaling to this. So this is going to be k over 6 into k plus 1 into 2k plus 7. Now you add this term. Remember, this wasn't there. So you add this side, and also you add it this side. So this will be now. So we are adding here k plus 1 into k. Okay, let me first expand this here into k plus 2 plus 1. So now, you see that now, for this, it was this. But because I've added this, I also add it to this side. So the only thing we've changed is adding this and also adding this. So this is the 1 term we are adding on the k terms. These are k terms. So we are adding 1 term. This we add both sides like that. Okay? Then our last step is simplify simplify the right hand side. So our right hand side, you see there, is going to be equal to, here I have k into k plus 1, 2k plus 7, the whole over 6, now plus k plus 1, into when we simplify that we get k plus 3. So that is the case I'm having. So it's the LCM, I'm going to cross multiply there. Here I have k squared, okay, k into k plus 1 into 2k plus 7, cross multiply, I get 6 into k plus 1, then k plus 3, the whole over 6. So that's the idea we are having. Now you see from here, this k plus 1 is common, so if I factorize it out, so k plus 1 is common. If I factorize it out, we are going to read it. I think this we have k into 2k plus 7, then plus what is common, we remove this out. So these are our big brackets. Let me create big brackets here so you can differentiate them. When I remove this here, I mean with this, then plus we remove it here, have 6 k plus 3. Sorry, they all over the big bracket. We are dividing the whole of this by 6. So now we can bring brackets there. So this will give us k plus 1, the whole over 6 into, now this is going to be 2k squared plus 7k plus 6k, which is 13k plus 18. So that's what we have, which you can simplify. You can factorize this into this is going to be k plus 1 into, you can factorize this. You see that two numbers are multiplied by 6. When I simplify, when I add, I get 9. So those are 4 and I think 9, 4 and 9, which you can factorize. So then our task is to factorize this. So if I'm factorizing this is going to be k plus 2 into 2k. Now you see 2k was common, so when we factorize out here, I think it's going to be 2k plus 9. So that is the idea. Factorizing this, you can factorize this into this. When you multiply this and this, you get k squared, this and this, you get k, this time this will get 2k squared, then this and this will get 9k, this will give us 4k, which will give us 4k plus 9, can get 13, then this and this will get 9, and then 18. So the whole of this over, now 6. So this is our right hand side. Now our task here is to remove our k, because the whole of this is in n. So we come back here, so that our n is equal to k. Now our task is to remove this k from this. So it's that now from n is equal to k. Okay. From here, you can see that our n was equal to our k plus 1 was equal to n. What does it imply? It implies that now our k is going to be n minus 1. So putting in the right hand side, what we are going to be having is, so where that is k, we put n minus 1 plus 1 into n minus 1 plus 2 into, multiply k by 2, we get to n minus 2 plus 9. The whole of this one was all over 6. So that our right hand side is equal to, this will cancel, have n over 6 into this will be n plus 1, then 2 n plus 7, and you see that our right hand side is equal to our left hand side, as you can able see. then we conclude. So it's that now, the right hand side is all we wanted to prove, which is there. So it's that our proof is there. Then we conclude, since it's true, for n is equal to 1, comma, n is equal to k, and n is equal to k plus 1, then it's true for all values of n. But of course, these are real numbers. I mean, in positive integers, true for all values of n. So that's how we handle that proof. Really easy. So never I tell you to prove by induction. Proof for n is equal to 1. It's just enough. This one was just proof for n is equal to 1. Assume it's true for n is equal to k plus 1. I mean, assume it's true for n is equal to k. Then handle when n is equal to k plus 1. The rest are going to be very easy. So that's it. Don't forget to subscribe to the channel. I wish you well.